Greetings! We are very glad to take part in the final round of iGEM 2021. And today, it is our pleasure to present to your honorable judges our product, the Soda's Health and Position Tracking System. The reasons for why we chose this topic are, in the 21st century, which is considered as an era of technology, IoT-based technology has been widely applied to many aspects of our lives, especially military modernization. The military plays a crucial role in securing national safety. However, as the situation of COVID-19 is more complicated than ever before, it is getting more and more challenging for nations to keep soldiers safe and healthy. Hence, monitoring their health status and vital signs is a critical task, which can be facilitated by IoT technology. Furthermore, IoT technology can help many countries in tracking soldiers' position, trip logs, and health status when they are on duty. So we came up with an idea of a soldiers' health and position tracking system. For the objectives of this project, Phong will introduce them.
And for the second part, there are three main objectives we want to achieve from our invention. Firstly, this device uses 5 special sensors to track the health index, vital sign, and position statistics of soldiers 24/7. Secondly, the collected information will be sent to surveillance server to analyze and also to detect any irregular sign. Therefore, suitable action or support can be conducted to save soldiers' lives. And finally, we create an app that connects our device with other smart devices, making it easier for the commander to know the condition of soldiers from the battlefield. And for the implementation process, it's long.
For implementation process, based on those goals, we started to build a basic system diagram including electronic circuits and components to our physics template, but we have to choose the exact sensor and set up the code for each component. The hardest thing in our process was to program the module A19 GPS. Next, we designed the case for our product based on the box form and program the main microcontroller to send the data to the main server. After all successful with the design, we uploaded the code, assembled all the components, and did the wiring. Also, we developed a mobile app to fulfill our initial requirement. Finally, our team completed the product and moved to the testing phase. This is a memorable experience summer 2021. Next, I will dive more deeply into the components.
We have integrated 5 sensors into a device, which includes, first, the SHT31 temperature and humidity sensor to collect both the temperature and humidity ambient in the environment. For monitoring soldiers' health data, we use the MEMLX90614 infrared thermometer to measure the body temperature. Next, we use the MAX3100 pulse oximeter and heart rate sensor. It combines 2 LEDs, a photo detector, optimized optics, and a low-noise analog signal processing to detect the pulse oximetry and heart rate signals. This is the MPU6050, a accelerometer and gyroscope sensor. This helps us to determine the orientation of an object. As for that, it can help us to get more accurate information related to soldiers' motions. Finally, the A9G GPS tracker module is the last piece of the puzzle. It is ideal for us to use this module to locate soldiers' position. All of the sensors above will use either the I2C inter-integrated circuit or UART communication protocol, and they are all cost-effective, optimal in size, and working efficiently. Now, all of the data collected from the sensors are directed to the Arduino Nano, which is the center board of the whole system. The Arduino first receives the signals from the sensors before converting them into understandable scales. All of the processed data are then sent to 2 places. First, it can be displayed on an OLED screen, which helps the soldiers to keep up with the data. Secondly, it can be transferred to a micro SD adapter, and which is connected to the module SIM 800L. Through this module SIM, the data is sent to the main server, as you can see on the desktop screen. And like the aforementioned objectives, we also create an app to have the authority to monitor soldiers' health data more easily, but only the authority will have this right, of course. In case of emergency situation, especially when the health data of soldiers are abnormal, a buzzer in the product will be activated to alert the soldiers about their problems, and simultaneously, an alarm will be sent to the system, to the authority systems, so they can make official decisions.
After finishing and testing it on 10 people at different conditions and different period of times, our product has effectively modeled health statistics, vital signs, and position data. The system has become fully automated with an acceptable standard error. Having an always on display screen allows the soldiers to easily adjust their behavior. The data from the device would be sent to the server that link the index with the applications. We are looking forward to innovating our inventions by firstly, improve the data securities, assure the national security. Secondly, it will alert the authority when the device is not used by the soldiers. Thirdly, it would warn about severe weathers, tough terrains, and area bombardments. Moreover, the device is designed to wear on the bicep so that the soldiers can freely move on the battlefield. And finally, the device can guide soldiers to safe places. In the near future, we want to have some improvements. Firstly, to upgrade our equipment. Secondly, to create suitable models for various functions and locations. Thirdly, the price will be optimized so that every national army force could afford to buy this. And finally, we would improve the functions so that it could fit with others, such as examining people with COVID-19. This is the end of our presentations. Thank you for listening.